Hello everyone, I am Chandras Mishra from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss Dijkstra's algorithm to find single source shortest path. Here we will see single source shortest path. After that, we will see Dijkstra's algorithm to find single source shortest path and complexity of the algorithm and application. So, before moving to Dijkstra algorithm, we should understand the source shortest path. Suppose we have a graph like this, and this is suppose this is directed graph. Here we want to find out the path from this vertex A to suppose this is O. Okay, B, C, D, E, and O. So what we need to find? We need to find out path from A to A. So what is path? Path is basically a sequence of vertices from one vertex to another vertex. So if we start from A, so we can see here there are multiple paths available to reach O. We can move from A to B. If we take here, we can move from A to B, then from B to C, and then from C to O. So this is one path. We can also go from A to E, E to E, A to E, and E to D, and then D to O. We can also visit from A to E, then E to B, B to C, and then C to O. So like this, we can have multiple paths, and each path is associated with some cost. If we have some cost like 2, 1, 3, 4, 1, 2, 5 like this. So if we calculate the cost of these this path, we have multiple cost. So to find out the minimum cost of the path is called minimum single source shortest path. So basically what we want to find out the path from A to other vertices, and what is the minimum cost for that. And for this, we'll use Dijkstra's algorithm. So let's begin with the Dijkstra's algorithm. So step one is, uh, first of all, we will initialize the single source. First, we will initialize the single source of this graph. And after that, set the weight of source vertex as 0 and weight of other vertices as infinity. After that, we'll create a priority queue for all the vertices. We'll insert all the vertices in the according to their weights, and then we'll extract the minimum from the priority queue. After that, we'll find the adjacent node and update the weight of the adjacent node of the extracted vertex if the current cost is less than the existing cost. And after that, we'll update priority queue. And then we'll repeat this step of 4 to 6 until the priority queue is empty. So this is the procedure to perform Dijkstra algorithm. So let's begin with an example of the graph. So suppose we have this graph and we want to find out the uh, path from for all the vertices, and the source vertex is this 0. The 0 is given as the source vertex. Let us mark it as the source vertex. So according to procedure, first of all, we'll build priority queue. So let's begin with the priority queue. Suppose we have a priority queue like this. This is a priority queue. And here we'll insert all the vertex of this graph. So vertices was 0, 1, then 2, 3, then we have 4, 5, 6, 7, and 8. So these are the vertex. Now the cost of all other vertices updated as initialized as infinity, and their source is nil. So we'll write just n for the source because source is unknown. So for unknown source, we'll just write nil. And the cost of this zero vertex will be 0. So cost of this is 0. Okay. Now what we'll do, we'll just find out the minimum cost vertex, that is the source. So we'll write source 0 here, and the cost of this 0 is 0. So here is the vertex. Here we are writing vertex, and after that we are writing the cost. So this is the cost, this is the cost, and this is the vertex. So to visit 0 from 0 is having 0 cost. Okay. Now what we'll do, we'll just update all the adjacent vertex of 0 and find if the cost, if the current cost is less than the existing cost, then we will update that. Okay. So adjacent vertex of 0 is 1 and 7. So what will be the cost of 1 is 0 plus 3, that is 3. So every time whenever we are computing the cost of this vertex, we will find out the cost of this vertex u. Suppose this is vertex u and this is vertex v, and we are computing the cost of v from u. So in that case, we have to add the cost of u plus cost of u to v, uv. That is the cost of this vertex, this edge. That will be the cost of this vertex. Okay. Suppose the cost of 0 is 0 and the cost of this edge is weight is 3. So basically we'll add this. You can write here WUV, that is the weight of UV, and that will be the cost of vertex V. So every time we will follow this. So the cost newly created updated priority queue will have the cost of this 1 as 3 and source as 0, and the cost of 7 will be 6. Vertex 7 is 6 and source will be 0, and we'll just copy other vertices as it is. So like this is infinity, 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 and source is unknown. So we'll write just n. And now here we'll select the minimum. So we can see here the minimum vertex is 3. Minimum cost is 3, belongs to vertex 1. So we'll select this vertex 1. So from 0 to 1, now the cost is 3. So we'll just write cost as 3. And the source of this 1 is 0. So 0 to 1. Will reach 0 to 1 in 3 costs. So it is already in the graph. After this, we will update priority queue. So let us adjust the update the cost of the adjacent vertex of 1. So adjacent vertices of 1 are 2, 7, and 0. So 0 is not present in the priority queue. So we'll consider only 2 and 7. So let us compute the cost of 2. So cost of 2 will be cost of 1 plus weight of this 1 to 2 is. So cost of 1 is what, 3, and the cost of this, the weight of this is 5. So 5 plus 3 is 8. So we'll write here 8, and the source will be 1. So we'll write 1 here. Same as we'll calculate the weight, cost for 7 vertex. So cost of 0 and we will add this one. So cost of now the adjacent vertex of 1 is 7. So the cost of 1 plus weight of the 1 and 7, 1 to 7 is is 9. So we'll add 3 plus 9, that is 12. So we'll update 7 as the 12 and source as 1. Now we can see here we have updated all the adjacent vertex of 1. Now we'll copy other vertices as it is. So infinity, 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 and unknown source. So we'll write n here, nil. Here also we'll write infinity and nil. Now we will extract min, because this is min priority queue, this is priority queue, priority queue, but this is min priority queue. So here we will extract min. So minimum is what 8, that belongs to vertex 2. So we'll take this. So vertex now 2 is here and the cost is 8. And now again we will update the cost of adjacent vertex of 2. So here you can see adjacent vertex of 2 is 3, 8 and 5. 3, 8, 5 and 1. So 1 is not present in the priority queue. So we'll just consider the adjacent vertex as 8, 5 and 3. So what will be cost of 8 is the cost of 2 and the weight of 2, 8. 2 to 8 is, we'll add this. So cost of 2, where we will find out the cost of 2. So here it is written, the cost of 2 is 8. So 8 plus 4 is 12. So cost of vertex 8 will become 12. So we'll update here 12 and we'll write source as vertex 2. Now what will be the cost of 3? So cost of 2 plus this weight of this is, that is 8. So 8 plus 8 16. So we'll update 16 at the place of 3 vertex and the source as 2. Now what will be the cost of 5 vertex? Cost of 2 plus weight of 2, 5, that is 2. So 8 plus 2, that is 10. So it will become 10 and the source will be 2. Now we'll copy other vertices as it is, like this. And for 6 we'll copy as it is. For 7 also we'll have this infinity, and so for 7 we have 12, 12 and 1. Now we'll extract min from this. So minimum vertex is minimum cost is 10 of the vertex. This vertex is 5. So we'll just select 5. We'll write 5 here. So 2 to 5. And the cost is 10. Cost is 10. Now we'll update all the adjacent vertex of 5. So we can see here the adjacent vertex of 5 is 6, 2, 3, 4 and 6. So 2 is not present in the priority queue. These are not present. These vertices are not present. So 1, 2, 0, 1, 2 are not present. So we'll not consider that. We'll only consider adjacent vertex of 5 as 3 and 4 and 6. So 3, 4 and 6. So let us consider compute the cost for vertex 3. So cost of vertex 3 is cost of vertex 5 plus weight 5, 3, that is 10. So 10 plus 10, it is 20. So cost of 3 is 20. So here it is very important to find out. Here it is very important to focus decrease key. So if the current value, that is 20, it is greater than the existing value 16, so we will not update it. So it is not eligible for updation. Now come to the vertex number 4. So cost of 4 will be what will be cost of 5 plus ACE. So here you can see the cost of 5 is so cost of 5 is 10 and the weight of 5 4 5 is 9. So 10 plus 9, that is 19. So the cost of vertex 4 is 19. So we'll write here 19 and source as 5. Now again and we will copy 16 here as it is, because no updation is there. Now come to the vertex 6. So the cost of 6 will become cost of 5 plus 1, which is the weight of 5, 6 edge. So it will become, so here we'll add this weight of this edge in the cost of 5. So 10 plus 1, that is 11. So we'll write here 11. This is 11 and source as 5. And we'll copy 12, 1 and 12, 2. Okay. Now here we will find out the minimum. So here we can see the minimum vertex is 6. So we'll just extract this mean and we'll write vertex. So vertex 6 is selected. So we'll write 6 and the cost of 6, vertex 6 is 11. Now come to the next iteration. Again here we will have, we'll update our priority queue. So you can see these all are removed from the priority queue, and this is also removed, and this one is also removed. So we have only 3, 4, 7, and 8. Now what we'll do, we'll just find out the adjacent vertex of 6 and update their weights if possible. So adjacent vertex of 6 is, we can see adjacent vertex of 6 is 7, 8 and 5. So 5 is not present in the priority queue, so we will not consider it. So we'll only consider 7 and 8. 7 and 8. 8, this one. We'll consider 7 and 8 as the adjacent vertex. So what will be cost of this 7 vertex? Cost of this 6 vertex, cost of 6 vertex plus weight of this edge. So cost of 6, where we have written here. So cost of 6 is 11 and plus 3, it will be 14. So cost of 7 is 14. But here we can see it is already having 12, which is less than the current computed cost. So we'll not update because this is not eligible. So we'll just copy 12, 1. Now come to A. So what will be cost of this? So cost of this will become cost of 6, that is 11 plus 5, it is 16. But already have 12, so we'll not update it. It will be 12, 1. Now any other vertex 5 is not present and other vertices are not eligible. So we'll just write 16, 2 and 19, 5. Now again we'll extract min from this priority queue. So we'll take this vertex 7 from the priority queue. Here we can have same cost value. So in that case we'll take the first one that in the sequence of their vertex number. So here we'll select 7 vertex and the cost of the 7 is 12. So we'll extract vertex 7 and we'll write the cost of this vertex as 12. Okay. After this, in the next iteration, we'll again update the weights of remaining vertices that are adjacent to 7. So let us find the adjacent vertex of 7. Adjacent vertex of 7 is 0 is not present in the priority queue. 6 is also not present and 8 is present. So here we can compute the cost of we can compute the cost of 8. So what will be the cost of 8? It will be the cost of 7 plus weight of this is, that is 6. So cost of 7 is 12 and the weight is 6. So we'll add this 12 plus 6, that is 18. So cost of 8 is 18. It is already having 12, which is less than the current one. So we'll not update this. It is not eligible. So we'll write this as it is 12, 1. And this is already removed from this. It is also removed. This is also removed. And any other is not adjacent. 3 and 4 are not adjacent to 6. So we'll just copy this 16, 2 and 19, 5. So again here we will extract min, that is 12 and the vertex is this 8. So we'll write 8 and the cost of this 8 vertex is 12. And again we'll update the cost of other vertices that are adjacent to 8. So adjacent vertex of 8 is 2, 7 and 6. So we can see here 2 is not present, 7 is also not present. It is already removed from this, and 2 is also not present. So there will be no changes. We will just copy this as it is, and here we will select no update in the weight, and here we will select the minimum one. So in 3 and 4 we have this 3. So we'll just select this and we'll write the vertex 3, and the cost of this vertex is 16. And now we'll update the cost of the try to find out the adjacent vertex of 3. So here we can see adjacent vertex of 3 is 5 and 2, 5 and 4, but 2, 5 and 4 are 2, 2, 5 and 4. 4 is present in this, and the will compute the cost of 4. So it will be cost of 3 and plus the weight from weight of 3 to 4. So we can see here weight of 3, 4 is 6, and the cost of the vertex 3 is 16. So 16 plus 6, that is 22, and we have already 19 here. So we'll not update this, and we'll select this one. So we can write here. So the cost of the 4 will be 19. Now we can see here all nodes are removed from the priority queue, and now the priority queue is empty. So whenever the priority queue is empty, we will stop and we'll write the cost of each vertex. So here we can see 0 to 1. 0 to 1 we have 0 to 1 we have cost, that is 3, and from 0 to 2 via 1. So 0, 1 and 2, the cost is 2. Here we have 3 and 2. After that we have 5. So the path will be 0, 1, 2 and 5, and that is 10. Now for 6 we have 0, 1, 2, 5 and 6, that is 11. And for 7 we can reach from 0, 0, 1, 2, 5, 6 and 7. It will become 12. And after that again we can write 0, 1, 2, 5, 6, 7, 8, and it is 12. For 0 to similarly for 0 to 3 we have 16 cost, and for 4 we have 19. So this is the cost of all the vertices from a 0. So this is very important algorithm, and it is used by binary heap if we are using binary heap. So let us try to find out what will be the complexity of this. So complexity of this algorithm will be E log B, because we have to update the weight for each edges, and for updation it is taking log V, that is the algorithm to update the cost of the vertex for each edges. So it will be order of complexity. And what is the application of this Dijkstra algorithm? It is very important algorithm for the network routing. In the network routing algorithm is created using this. Routing algorithm is created using this. So distance vector routing, DVR is following this Dijkstra algorithm. These are the references of used in this video. Thank you for watching this video.